Welcome to another deep dive, listeners.
Yeah.
Today we're going exploring data drift.
Data drift.
Yeah, data drift. It might sound, well, a little bit technical,
Uh,
but trust me, it's something that I think pretty much anyone who works with data should at least be aware of.
oh, absolutely. Especially in this age of, data-driven decision-making every way you look.
Exactly, exactly. And basically, data drift is this sneaky phenomenon where, the data that our systems rely on,
Right.
it starts to change over time.
It does. It does. And, it can be really subtle. It's like almost like a slow leak in your data
Oh,
pipeline.
that's a good analogy, a slow leak.
Yeah, it's gradually, eroding the accuracy of your models, your insights, your decisions.
And so I guess the question is, why should we care? What's the big deal if our data shifts a little? Things change, right?
Well, think about it this way. Imagine you're, let's say, a bank.
Oh,
And you're using a model to predict, whether someone's likely to default on a loan.
mm,
So you've trained your model, on all this historical data, past customer behavior, all that.
right.
But then what if suddenly people's spending habits change drastically? Like let's say there's a recession
Uh-huh.
or maybe some new technology comes along and totally disrupts the market.
Yeah.
Suddenly that model that you were relying on, its predictions become, well, unreliable.
Yeah.
And that could lead to, bad loans, financial losses, all sorts of
Yeah,
problems.
that's a real tangible example of how this could actually play out.
And it's not just banks. I mean, this data drift thing, it can impact any business, any organization that's using data to make decisions.
For sure. So I guess the big question then is, how do we actually spot it? How do we detect this data drift before it causes these problems?
Well, that's where our sources point us to a really interesting statistical tool
Hey
called
there.
Kullback-Leibler divergence.
Kullback-Leibler. Okay. Is there like a shorter way to
Yeah, you can just call it KL divergence for short.
KL divergence? Okay.
And essentially, KL divergence helps us measure how much one probability distribution diverges from another.
Okay. And so in simpler terms, how would you explain that?
Okay, so imagine you have two bags of candy, right?
Right.
Each bag has a different mix of flavors.
Okay.
KL divergence basically tells you how surprising it would be if you reached into one bag expecting the mix of the other.
Oh, okay.
So it's the mix is pretty similar. The KL divergence is low.
Mm-hmm.
But if you reach into one bag expecting, mostly chocolate and you get a handful of like sour candies, well,
That's a high KL divergence.
exactly. That
Yeah.
means the distributions are quite different.
Okay, so I'm starting to get the picture here.
Hmm.
So we can use this KL divergence to compare our current data to like a baseline data set from the past.
Right, exactly. You have your reference point, your baseline, and then you compare it to your new data.
And if that KL divergence is high, that means our data has drifted significantly, like those sour candies.
Precisely. And that drift, it could be a sign of something important changing in the real world. Like maybe customer behavior has shifted, maybe
Mhm.
there's a new trend emerging, or maybe sometimes it can just be a sign that there's an error in your data collection process.
Okay, so it's like KL divergence is like our smoke alarm,
Oh, I like that.
alerting us to potential data fires.
Yes. And just like with the smoke alarm, once we get that alert, we need to investigate, figure out what's causing it.
Absolutely. So speaking of real-world examples, our sources actually delve into a specific scenario, a banking example, to illustrate how this all plays out in practice.
Oh, yeah, a great
So
example.
can you set the scene for us?
Sure. So imagine we have this bank, right?
Right.
And they're using a customer behavior model, or we can call it CBM for short,
CBM, got it.
to basically assess credit card holders. The CBM score, it helps them make decisions like whether to automatically renew a credit card.
Right, right.
And they had this well-established system. Everything was running smoothly. Renewal rates were great, like 95%.
Okay, so most people were getting their cards renewed automatically.
Yeah, no problems. But then suddenly they see this dip.
Mm.
Renewals drop to 90%.
90%, so not a huge drop, but
It might not sound like a lot, but when you're dealing with millions of customers,
right.
that means thousands of people are now facing manual review. It's creating a backlog, causing frustration.
Yeah, I can imagine the customer service nightmares.
Exactly.
So what happened? Did the customers suddenly become less creditworthy?
Well, at first the bank thought, yeah, maybe it's a change in customer behavior.
Right.
But they dug a little deeper, and the analysts uncovered a glitch, a data processing error.
Oh.
It turned out one of the data feeds from a credit bureau they were using was sending inaccurate information.
What?
And this error, it affected the CBM score, led to lower scores for some people, and ultimately those automatic renewal denials.
So a classic case of garbage in, garbage out, huh?
Yeah, pretty much. And it just shows how, a seemingly small data error can snowball into a major operational headache.
For sure. And it emphasizes why catching these data drifts early is so important.
Absolutely. It can prevent those nightmares, save money, keep customers happy.
So let's bring it back to Kale divergence, our data drift detective.
Right.
How did it come into play in this banking scenario?
Well, in this case, they used a specific variation of Kale divergence called the Population Stability Index.
Okay, another acronym.
Yeah, PSI for short.
PSI, got it.
And PSI, it's particularly useful for comparing data distributions in real-world applications like this.
Okay, so how does PSI actually work in practice? I mean,
Yeah.
how do we use it to spot these drifts?
Think of it this way, like sorting your laundry.
Okay.
You divide your data into different baskets, just like you separate your clothes into whites, colors, delicates.
Okay.
We call these baskets bins.
Bins, got it.
They represent different ranges or categories within your data.
So instead of clothes, we're sorting data points based on their values, right?
Exactly. And then we compare the percentage of data points falling into each bin.
Okay.
In our baseline data set, that's like our perfectly sorted laundry pile from the past,
Mhm.
to the percentage of data points in the same bins in our current data set.
So if the percentages are similar, it means our data is stable. Like our laundry habits haven't changed.
Right. But if we see big discrepancies, that's our red flag.
Oh, like suddenly we have way more socks than we used to.
Exactly. Something's up. And PSI basically crunches those numbers, gives us a single value
Ugh.
that tells us how much our new data set has drifted from the baseline.
So I think I'm following. We have these bins, we compare percentages, and PSI tells us if our data is acting up.
You got it.
But how bad does the PSI score have to be before we, sound the alarm? Are there any guidelines?
There are. There are. Typically, if the PSI is below zero point 0.1, things are pretty stable.
Okay.
No need to panic. Between 0.1 and 0.2, that's like a yellow flag.
Okay.
Something might be brewing, worth investigating. But above 0.2, that's a red alert. Significant drift is happening.
So it's like a data drift Richter scale. The higher the PSI, the bigger the problem.
That's a great way to put it. But, these thresholds, they're not set in stone.
Right.
Different businesses might have different risk tolerances.
Makes sense.
Like a financial institution dealing with, sensitive data, they might have a much lower threshold for concern than, say, an e-commerce site tracking click-through rates.
Yeah, the stakes are different.
Exactly.
So in that banking example we talked about, their PSI must have been off the charts when those renewals plummeted.
Oh, you bet. And that's what's great about PSI. It doesn't just tell you there's a problem. It helps pinpoint where the problem lies.
Oh, how did you do that?
It highlights those bins with the most significant discrepancies.
Okay.
So in the bank's case, PSI would have flagged those lower CBM score ranges where that data processing error hit the hardest.
Ah, so instead of like combing through mountains of data, they could zoom right in on the trouble spots.
Exactly, exactly. Early detection is key.
That's some serious detective work. So they use PSI to find the problem.
And what's even more impressive is that the researchers in our source material, they didn't stop there.
Okay.
They wanted to really put PSI through its paces, so they ran simulations.
Simulations.
Yeah, like creating their own mini data disasters.
Mini data disasters. Okay, this is intriguing.
So they took various data fields, things like ad response, sales volume, deposits, even those same CBM scores from the banking example,
Okay.
and they intentionally injected them with real-world errors.
Real-world errors, like what kind of errors?
Things like missing values, inconsistencies in units, the kind of stuff that can slip through the cracks even in well-maintained systems.
So they were basically playing data gremlins, trying to break things and see if PSI could catch them.
Exactly. They wanted to see how PSI would perform under different types of data drift and see if it could pinpoint the source of the problem.
Okay, I'm on the edge of my seat. How did PSI hold up against those data gremlins?
It's like a champ. It consistently flagged the drifts, accurately identified the areas affected by those injected errors.
Wow, so it really is like a data bloodhound sniffing out those inconsistencies.
Precisely. And this shows that PSI isn't just about detecting drift, it's about diagnosing it, understanding where the problem originates.
This is fascinating. So we can use PSI to detect the drift,
Yeah.
pinpoint its location, and even tell us how severe the issue is.
Exactly. And that's where this deep dive gets even more interesting.
Yeah.
Because the simulations also revealed some nuances about how PSI works, especially when it comes to the number of bins we use.
Those data laundry baskets.
Exactly. The size of those bins, how many we have and how wide they are, can actually influence how sensitive PSI is to detecting those subtle data shifts.
So it's like adjusting the zoom on a microscope, right? Finer detail versus broader view.
Precisely. And we'll dive into those fascinating details in the next part of our deep dive.
Okay, you've definitely piqued my curiosity. Stay tuned, listeners, as we delve deeper into the world of data drift and explore those nuances of PSI in the next part of our deep dive. All right, we're back and ready to unpack those fascinating details you mentioned about those data bins.
Right, those bins.
We're talking about how they impact PSI.
So remember how we were saying those bins, they represent different ranges or categories within our data, like sorting our laundry?
Yeah, like whites, colors, delicates, all that.
Exactly. Well, the size of those bins, like how many we have and how wide they are, it can actually make a difference in how sensitive PSI is
Okay.
to detecting those, sometimes subtle data shifts.
So is it kind of like adjusting the zoom on a microscope?
Yeah, that's a good way to think about it.
Like finer detail versus a broader view?
Exactly. So in their simulations, the researchers, they tested PSI with both 10 bins,
Okay.
which are called deciles, statistically speaking,
It's like, got
and 20 bins,
Okay.
which are called demideciles.
Demi-decile. All right, so double the bins.
Yeah, just to see how it affected the results.
And what'd they find? Did more bins mean like better accuracy in catching those data gremlins?
In most cases, yes. Using more bins, those demideciles, it generally made PSI more sensitive, so it was picking up on even slight divergences
Okay.
that the broader deciles might have missed.
So more bins, better detection, case closed.
Well, not so fast. It's not always that straightforward.
Okay.
Remember, with PSI, it's all about finding the right balance, right?
Right.
Because if your bins are too narrow, you might end up flagging tiny, insignificant fluctuations as major drifts, and then you have a bunch of false alarms.
Oh, so like crying wolf too many times.
Exactly. And then you start tuning it out even when there is a real problem.
Right. So finding that sweet spot is key. In those simulations, were there any specific times where the bin size actually made a noticeable difference?
Yeah, actually, the ad response data field is a good example.
Okay.
Remember those incomplete files from ad platforms that we talked about?
Yeah, the missing data points.
Right. Well, when they used deciles, those 10 bins, the PSI was just below that typical zero point 0.1 threshold, so it looked like things were okay.
Okay.
But then when they switched to demideciles, double the bins, the PSI jumped up to 0.11.
Oh, so it crossed that proceed with caution line.
Yeah, exactly. So the finer resolution, using more bins, it revealed a potential issue that the broader view might have missed.
It's like those missing values were hiding in plain sight.
Yeah, they were lurking there. And this really highlights why it's so important to understand your data, right?
Yeah.
Because for something like ad response, where even small fluctuations can be significant, that increased sensitivity from the demideciles, it could be crucial to catching those subtle but important shifts.
This is all making a lot more sense now. So PSI, it's kind of like this multi-tool for data quality control.
I like that.
Like detecting the drift, telling us where it's happening and how bad it is.
You got it. And what's even more amazing is that for all its power, PSI is actually pretty simple to calculate.
Really?
Yeah.
I was picturing like complex algorithms and all sorts of, fancy code.
Nope. As our sources point out, you can actually do PSI calculations right within your data processing pipeline using SQL.
No way. So you don't need like special software or anything.
Not necessarily.
That's incredible. It's like having this built-in safety net constantly monitoring your data for any signs of trouble.
Yeah, exactly. And that's what makes PSI so valuable, especially now with, AI and automation being used everywhere, because businesses are relying more and more on data-driven decisions.
Right.
So having this early warning system in place,
Right.
it can really be the difference between smooth sailing and hitting those data icebergs,
Okay, so to recap, PSI, this handy variation of KL divergence, helps us detect and diagnose data drift, which is like super important for making sure our data is good and that our, AI systems are reliable.
You nailed it.
But there's one more thing I wanted to touch on. Those PSI thresholds?
Oh, right.
Remember those proceed with caution and red alert levels?
Yeah.
Well, I'm curious. Like, is it always as simple as just using those standard point 1 and point 2 guidelines?
It's not always that simple. No,
Okay.
PSI is powerful, but it's
Hmm.
only as good as the way we use it, right?
Right.
Setting those thresholds thoughtfully, considering the specific context of your data and your business, that's really key to avoiding those false alarms
Okay.
and making sure you're focusing on the drifts that really matter.
So it's like setting the sensitivity on a motion detector, right?
Yeah, I like
Too
it.
sensitive and it's going off all the time, not sensitive enough, and someone could, walk right by.
Exactly. And a lower threshold, you might catch more potential drifts early, but you also might have more false positives to sort through.
Right.
A higher threshold, fewer false alarms, but you might miss those subtle shifts.
So it's about finding that balance between catching things early and not having too many, fire drills.
Exactly. And that's where understanding your data, your business context really comes in.
Hmm.
What's the cost of a false positive? What's the impact of missing a real drift? Thinking about those questions that can help you figure out what the best threshold is for your situation.
Okay, so it's almost like a choose your own adventure for data quality control.
In a way it is, and that's what makes this field so cool.
Yeah.
There's no one size fits all. It's all about understanding your data, your goals, and figuring out the best approach.
So we've talked about KL divergence, PSI, bins, threshold. Are we missing anything in our data drift detection toolkit?
Well, there's one more crucial piece that we can't forget about.
Okay.
The human element.
The human element. You mean it's not all just algorithms and automated systems?
Definitely not. These tools, they're powerful, but they're not magic.
Okay.
They're meant to help us, not replace us.
Right.
Our judgment, our expertise.
So even with all these fancy metrics and simulations, we still need like those sharp-eyed data detectives to interpret the results.
Absolutely. It's those data detectives who can look beyond just the numbers, understand the context,
Right.
and ultimately decide what actions to take. They're the ones who can connect the dots between a flagged drift and a potential root cause, like that data processing error in the banking example.
Okay, so it's like having a smoke detector. It alerts you to the problem,
Yeah,
but it's up to you to figure out if it's a real fire or just burnt toast.
exactly. Those data detectives, they're the ones making those judgment calls and making sure that those flagged drifts are addressed.
So we need both. We need the technology and the human expertise working together for a truly, uh, I guess, robust data quality control system.
I think that's a great way to put it. It's that combination that lets us really use the power of AI and automation, but still stay in control
Yeah.
and make sure our decisions are based on solid data.
This has been a really eye-opening deep dive. I feel like we've learned so much about how to detect data drift
Me too.
using KL divergence and PSI
Yep.
and the importance of those bins and thresholds and even, the essential role of those data detectives out in the real world.
It's all connected.
It is. But wait, there's more. We still have a little bit more ground to cover on this topic, so stick with us as we wrap up our deep dive into data drift detection. All right, we're back and ready to wrap up this fascinating deep dive into data drift detection.
It has been fascinating, hasn't it? So much to uncover.
It really has. We've covered a lot of ground from, understanding what data drift even is and why it should matter to us
Right.
to, exploring those powerful tools like KL divergence and, of course, its practical cousin, PSI.
And how to actually put them to work, yeah.
Exactly. But before we officially close things out, I want to make sure our listeners walk away with some key takeaways.
Oh, absolutely. Great idea.
Especially for anyone who's, eager to actually start using these concepts in their own work.
Yeah, so for anyone out there thinking, okay, this is great, but where do I even begin?
Right, exactly.
I think the first thing to remember is that, simplicity is key.
Okay.
Because, even though PSI has its roots in some, pretty complex statistical theory, it's remarkably straightforward to implement and interpret.
Okay, so you don't have to be like a math whiz or anything.
Not at all. I mean,
Okay.
anyone working with data can understand and use it, really.
That's good to know. That's good to know.
Yeah.
What else should people keep in mind?
Well, I'd say another big takeaway is to, don't be afraid to run those simulations.
Right, those mini data disasters we were talking about.
Exactly, because you don't want to wait for, a real data disaster to hit you. Right.
Out in the wild, so to speak. Create your own controlled chaos, test things out, see how PSI performs in different situations.
So it's like a dress rehearsal.
Yeah, exactly. For your data quality control system.
I like that analogy. Okay, so run simulations. What else? What else is on your must-know list for data drift detection?
I'd say, always, always, always remember that context is king.
Okay, context is king.
It is. It is because PSI and all these other drift detection methods, they're powerful.
Uh-huh.
But they're not magic, right? They're tools to help us.
Mm-hmm.
But we still need to understand our data in our business.
Right.
So thinking about what metrics really drive your decisions,
Mm-hmm.
what are the potential sources of drift in your pipeline? Those are the kinds of questions that can really guide you in setting those PSI thresholds,
Right.
really, really interpreting those results.
So it's not just about looking at the numbers, but understanding what those numbers actually mean for your business. Absolutely. And that's where, we come back to that human element that we were talking about before.
Right, those data detectives.
Exactly. They're the ones who can, bridge that gap between the technical side and the business side.
They're the ones who can see the whole picture.
They can, and they're the ones who can ultimately make those informed decisions.
Well, I think we've given our listeners a lot to think about today, and hopefully some practical tools to take away with them.
I hope so too.
We've talked about how to detect data drift using Kale divergence and PSI,
Right.
the importance of those data bins and setting those thresholds,
Hmm.
and we've even touched on the crucial role that those data detectives play in all of this.
Absolutely. It's a team effort.
It is. It is. So any final thoughts from you before we wrap things up completely?
I just say, to everyone listening, I really encourage you to go check out the source material, especially that GitHub link with the code examples.
Yeah. Oh, yeah, yeah.
Get hands-on, experiment, really see how PSI can help you keep your data in good shape.
Play around with it.
Exactly. Because, in today's world, knowledge is power,
It is.
and reliable data, that's the foundation.
That's a great point. Couldn't have said it better myself. So a huge thanks to you for guiding us through this really fascinating and essential topic.
My pleasure.
And to all of our listeners out there, stay curious, keep exploring, and until next time, happy data diving.